crap. Number 1. In this problem, assume the distribution of differences is approximately normal. Note degrees of freedom of the student's t-table. Use the closest one that's smaller. Okay, we don't have to worry about that. Is fishing better in a boat or from the shore? Pyramid Lake is located in the Paiute Indian Reservation, Nevada. Presidents, movie stars, and people who just want to catch fish and go Pyramid Lake and really large cutthroat trout. Let B represent the hours fish per fish caught on the shore. Let A represent the hours per fish caught using a boat. The following are paired by the month. So there's pairing here. There's two groups, but they're paired by month. Okay, so there's pairing involved. So we're going to use the paired inference procedure like we learned today. Use a 1% level significance to test the difference in the population means per hour caught for fish using the boat using the shore versus the shore. What's the level of significance? So 1%, so 0.01. Now, there's pairing involved. So if there's pairing involved in the groups, we're going to use mu d. So that means mean difference. And so we're trying to test the mean difference, the mean difference between the boat versus the shore. So we assume the mean difference is equal to 0. And what am I trying to prove? If there's a difference. Now, do they tell which direction the difference is? Do they tell which direction? What are y'all thinking for the alternate? Alternate, if they're trying to tell there's a difference, it'll be not equal to because there's a difference. So that just means one's different from the other. Okay, so we assume that there's no difference, and we're trying to prove there is a difference. And it's a two-tailed test because mean difference, I'm like seeing if it's off either to the left or to the right. What sampling distribution do we use? Okay, so what sampling distribution do we use for the means when we don't know the population standard deviation? We use the T, and we assume that has approximately normal distribution. So we assume that it's approximately normal. It's not uniform, it's approximately normal. So now we'll get into the procedure. So I'm going to click use salts. I can move over here. So I'm going to go to inferential statistics. All right. And after that, you're going to use paired T. Paired T. All right. So the difference contains the raw data. So these values right here contain the raw data right here. That's the raw data. And so they're wanting to do B minus A. So I need to put B first and then A second. They already default to that. So that's good. Hypothesis test. Hypothesized difference is going to be 0 because that's our null hypothesis. And I'm trying to prove it's not equal to. So this was already set up for me. That worked out nice. So I'm going to move this over, generate results. So my T statistic, traditionally, they'll go 3 spots on the T statistic. 3 decimal places, yes. 2.202. And then where's my p-value at? It's 0.0699. So which category does that fall into? 0.0699 is between 0.05 and 0.1. Okay. Now, what's my curve look like? Well, remember, it's different. So it's a two-tailed test. So you're going to have 2 tails shaded. So you're going to have 2 tails shaded. It's different. Now let's make our conclusion. Is the p-value less than alpha? Is 0.069 less than 0.01? Is it less than alpha? No. So when it's greater than alpha, we fail to reject, and it's not significant. When it's less than alpha, we reject. So when p is low, reject hope. But our p-value is above that, so we're going to fail to reject and conclude it's not significant. So fail to reject is like saying not guilty, so not significant. So when we fail to reject, there's insufficient evidence to claim that there's a difference in between the boat and the shore. So we don't have evidence to prove that fishing on the boat, there's a difference between fishing on the boat versus fishing on the shore. So there's yes. Okay, number 2. The problem, assume the distribution of differences is approximately normal for degrees of freedom. Use it, but we're going to use salt. We're going to cheat on this. At 5 weather stations on Trail Ridge, Rocky Road, the peak wind gusts in January and April are recorded below. So here's the thing. I know it looks like 2 samples like what we're going to do tomorrow, but this is paired. It's paired by weather station. So it's paired by weather station. So this is called paired data. Okay. So does this indicate that it's higher than January than it is in April? Use alpha 0.01. What's the level of significance? Well, they just gave it to you. It's alpha. State the null and alternate hypothesis. So we're assuming we're doing its paired data. So we're going to use the mu d, mean difference. We assume it equals 0. And we're trying to prove it's higher than January. So note that they're doing January minus April. So what must be true about this difference if it's higher? If it's higher, that means January's got to be greater than April. So if the first one's bigger than the second one, that means the difference has got to be greater than 0. Okay? Which distribution will we use? Well, we're going to use the student's t, and we're going to assume it has approximately normal distribution. They told us up here. They made a note of that, I believe. Yeah, we assume the distribution of difference is approximately normal. What is the sample test statistic? So I'm going to have to click use salt every time because it's going to load the data. So I have to click use salt. Yesterday, I just had to click use salt once and it did it. But so use salt. So I'm going to go to the inferential statistics. It is a paired T because we got paired data. The first one was January, remember? And the second one was April. They already preloaded it. Hypothesis test, the mean difference is 0. And I'm trying to prove it's greater than because it was what I had in my null hypothesis here. I'm trying to prove it's greater than. So it's a right-tailed test. Okay. And then move this out of the way. We have a t statistic of 1.105. And then a p-value of 0.1656. So 0.1656. That's between 0.125 and 0.250. And remember, this is a greater than. So greater than's a right-tailed test. So this is a right-tailed test. So it'd be right-tailed. So when p is low, reject TO. So how does our p-value compare to alpha? Our p-value is it's going to be greater than 0.01. So it's greater than, so we fail to reject, and it's not statistically significant. So when it's greater than alpha, we fail to reject, and it's basically saying not guilty, not significant. And so when you fail to reject, there's insufficient evidence. So we don't have evidence to prove that it was higher in January, that it was significantly higher in January. All right. Number 3. And the problem, assume the distribution is approximately normal. The differences, degrees of freedom, we've talked about that. The Western United States is a 4-lane interstate highway that cut through the long tracts of wilderness. To prevent car accidents from wild animals, the highways are bordered on both sides with 12-foot high woven wire fences. Although the fences prevent accidents, they also disturb the winter migration of many animals. To compensate for this disturbance, the highways have frequent wilderness underpasses designed exclusively by deer, elk, and other animals. In Colorado, there's a large group of deer that spend their summer months in the region. One highway survive the winter months. The lower side determined the highway has disturbed deer migration in the winter feeding. The following data were gathered by a random sample of 10 wilderness districts for the winter feeding area. Row B represents the average January deer count before the highway was built, and then A is January deer count after the highway was built. The highway department claims the January population has not changed. Tests the claim against the January population has dropped. So use a 5% level of significance. Okay, so on this one, first off, note that we have paired data. So this is called paired data because it's paired by district, they've got a before and after measurement. So this is called paired data. So we're going to use the paired data inference on this one. Level significance is 0.5%, so 0.05. Now, state the null and alternate hypothesis. So you're going to have to do something a little different here. You're going to use mu, but you need to have the subscript value. I got to find that in here because I need to do a subscript. Right there. So it's functions and then function sub. And I think I could do the mean first. Let me do the mean first, mu. So mu is right there. And then I'm going to go to functions sub. And that will give me the subscript. So mu d, and then get out of there, equals 0. Now I'm trying to prove if it has dropped. Now be careful though. It's basically as dropped. So before and after. So basically we're saying the after is less. It's dropped. So this is less. But my difference is before minus after. So if I'm doing before minus after, if the second one's dropped, that means the second one's smaller in the difference. So that means the first one's bigger. So bigger minus smaller should give me bigger. So this will be greater than 0. So I'm going to do mu functions sub and then greater than 0 because I'm trying to prove that the difference that it's got the after is less. So before minus after, I'm trying to prove that difference is positive. Which test will I use? Left tail, right tail, or two-tailed? It's greater than. Greater than is right-tailed. What sampling distribution will we use? We're going to use the student's t because it has approximately normal. And then we're going to need salts. Okay. So I'll click use salts. All right. So I'm going to go to inferential statistics. And we're going to do a paired t procedure. Raw data. So we're going to do before minus after. Before comes first, after comes second. Hypothesis test, 0, and then it's going to be greater than. Okay. So 0 and greater than. Let me move this out of the way. Show results. And so I've got a t statistic of, and it's going to be 3 spots usually, 2 decimal places this time. Okay. 3.46. And my p-value is 0.00357. So this is going to be 0.0035. So it's lower than the smallest one here. Lower than 0.005. So it's a right tail test. So I need the right tail to be shaded, and it's going to be very little shading because only 0.3% of it's shaded. Okay. When P is low, reject ho. Okay. So is P lower than alpha? Is our P value, which is 0.003, lower than 0.005 or 0.05? Yes. So we reject ho. And when you reject ho, that's like saying guilty. So you have significant evidence. It's statistically significant. So we have sufficient evidence to claim the January mean population of deer dropped. So we could say we have sufficient evidence to say that when they built the highway, that the number of deer in that area dropped. So that's paired, and as I said, it's a little bit, can be kind of a little tricky there on that, but we'll look at 2 sample ones tomorrow.